Hello friends, now let's talk about differentiation of parametric equations. And first of all, what are parametric equations? Parametric equations is equations expressed in terms of a third variable set t. For example, we can have y equal to t squared, and then also x equal to 3t plus 1. Then we have the parametric variable here being a t. And so normally, whenever you get such cases, we shall be using chain rule in order to get the derivative of parametric equations. And so which rule would we apply here for chain rule? So we shall have our derivative dy dx being equal to dy dt times dt dx like that. And then so let's try to get the dy dt and the dt dx, and then we substitute into this formula. So we shall have dy dt being equal to a 2t. This is an explicit function. It will be 2t. And then we have dx dt. So it will give us a 3. But you note that here in our formula, we want dt dx. And then from here, when you differentiate, we get dt dx dt. So how are you going to get dt dx? You note that you can note this and say that dt dx is equal to 1 over dx dt. So you just take the reciprocal of dx dt, and then so it means that here our dt dx is going to equal to 1 over 3 like that. And then so after getting that, we can substitute that into our formula. We shall have dy dx being equal to dy dt, which is 2t times dt dx, which is 1 over 3. We shall have 2t over 3 as our derivative function. It's our first derivative function. And then so let's have a look at another example. So assuming that we have our function y, equal to 1 plus 2t, and all of these to power 3. And then we also have x equal to t cubed. So how do we get the derivative function for these parametric equations? Now we still have the parametric variable as t. We shall say that still dy dx will equal to dy dt times dt dx, alright, like that. And then so we shall have dy dt. So you note that in this case, this is a function of a function. So you can let this 1 plus t2 equal to a u, and then you first differentiate only this y with respect to u, only this y. You differentiate it with chain rule alone. So then, but then, if at all you watched my previous video of chain rule, let's try to work it out simply or in a quick way. So we say that when you have such a bracket, you can first differentiate it as it is. So we shall first drop the power. So then 1 plus 2t, power 3 minus 1, it will be a 2. And then after that, you differentiate what's inside, you multiply it by this expression here. So when you differentiate what's inside, when you differentiate a 1, it will give us a 0. And then when you differentiate 2t, it will be a 2. And so this one, it will simplify to 6 into 1 plus 2t squared, right, like that. So that is our dy dt. And then what is dx dt? So dx dt is simply equal to 3t squared. And so if you don't know how we came to this, you can watch my previous video about chain rule. And then so this is our dx dt, but remember that we want dt dx, so dt dx is 1 out of dx dt, or you take the reciprocal of dx dt, and then we shall have this being equal to 1 over 3t squared, right, like that. And so when we substitute into our formula here, we shall get dy dx being equal to dy dt, which is 6 into 1 plus 2t squared. A squared, it's on the whole bracket, and then this divided by, or multiplied by 1 over 3t squared, which is the same as dividing it by 3t squared, like that. And then so finally we shall get to dy dx being equal to, this 3 can reduce that way 2 into 1 plus 2t squared bracket squared over t squared, like that. And then so at that step we have obtained our derivative function for the given parametric equation. Now let's also look at another example. And then so this one, assume that we have our function y. Assume that we have our function y equal to t squared over 1 plus t. And then we also have x equal to t over 1 plus t, like that. So now, even this one here, we shall have our formula as dy dx being equal to dy t times right dt dx, like that. And so when we get to that, but then remember that now this alone, it's a quotient, and even this one here alone, it's also another quotient. So it means that you have to first get dy dt, this one here, and then dx dt as a quotient using quotient tool. So let's begin with dy dt. And then so you happen to note that if at all this is my y being equal to t squared over 1 plus t, I can say that this is going to be my u and this will be my v. So we shall have dy dt equal to, remember the formula is v du dx minus u dv dx. So in this case it is a t, it will be v du dt minus u dv dt over a v squared. So this is my u, and then this is my v, this is my v. So we shall have v is 1 plus t, then du dt, in this case when you differentiate 2 squared it will be 2t, minus u, which is t squared, dv dt, which is a 1 because we have 1 plus t. This is a 0, and then this one here, it will give us a 1. And then we have the whole of this here being divided through by v squared, and our v squared is 1 plus t brackets squared, like that. And then so we shall get our dy dt being equal to, and when you simplify this is 2t squared, 2t plus 2t squared minus t squared, the whole of this divided by 1 plus t bracket squared, and this one here it will give us t squared plus 2t over 1 plus t bracket squared. Now so let's also try to get dx dt aside here. So dx dt will equal to, remember this is also a quotient because we have one function in terms of t being divided by 1 plus t. So we shall have v du dt. So our v, we shall say that this is going to be our u, the numerator, and then this is going to be our v. So we shall have v, which is 1 plus t, then du dt, which is a 1. This one here it is simply 1 minus u, which is a t, then dv dt, which is also a 1. Is a 1 here, and the whole of this is being divided through by 1 plus t squared, right, like that. And then so when we simplify this, we shall get to dx dt being equal to 1 plus t minus t. This is 1 plus t minus t to give us 1 out of 1 plus t brackets squared, right, like that. And then so let's substitute this, but remember that we want dt dx. So dt dx is going to equal to, remember we take the reciprocal of this, and then we shall just have 1 plus t squared. So let's substitute this into this formula here, and then so we shall get our dy dx being equal to dy dt, which is t squared plus 2t, this divided by 1 plus t bracket squared, multiplied by, remember we've converted the dx dt to dt dx, multiplied by 1 plus t squared, right, like that. And then this will cross out with that, then we shall remain with dy dx being equal to t squared plus 2t, and then so that is our derivative function for this given equation here, which was y equal to t squared of 1 plus t, and then x equal to t out of 1 plus t. Right, so that's it all about parametric equations, and then in the next video I'll make a video for trial questions and questions with solutions. Thank you for watching. Don't forget to like, share, and comment.